Hello everyone and welcome to my video series on FunctionalJ.io. In this video, we'll discuss how FunctionalJ.io can help you create and use immutable data in Java. FunctionalJ.io is a library that helps you write functional style of code in Java. You can visit FunctionalJ.io to learn more. The list of features, you click on the features, you can see example code there. This video is a companion for a blog post I wrote called Immutable Data with FunctionalJ.io on dzone, as well as my own blog. So you can go there and read for more details or example code if you want. Immutability is an important concept in functional programming because changing an object state is considered to be a side effect. And to avoid that, the best way to avoid that is to make an object unchangeable or immutable. There are already existing libraries that help you do this, like Lombok value or immutables, or you can write your own. So FunctionalJ is similar to those libraries, but it has its own unique functionality as listed here. So let's see how FunctionalJ can help. I have an empty project here that I set up to work with FunctionalJ. Please see the description below for a link to video that show you how to set this up. It's a few steps, but you need to follow some steps, that's all. So let's say I create a class called try struct. So let's say I want to create a data object called person. And a person has first name and last name. What I have to do is to create a method. This method will be called specification method. And then I annotate it with struct. Once I save, notice that a class called person, which is the same name with the method, is created with whole these two fields. Let's see how can we gonna use it. I use Java 10 var, a local variable, for buffering, but FunctionalJ.io works with Java 8, so you can do it your Java 8 style you prefer. So let's say I create a person and his name is Bruce Wayne. Then I can make use of that person. So if I print it, you see that it shows the first name and the last name right here. So as you may expect, the struct will generate a default toString object that has both of the fields in there, or whatever your fields you have. It also creates hash code and equal. As a value object, the hash code will be equal if the value of the fields are equal. So even though I have this object created here and another object created here, because the value are the same, you got the same hash code. Similarly, the equal method is created as well, and the object are equal if the value of it are equal. There. So far so good. This is similar to Lombok value and immutables. So now let's see how can we access the fields of the object. So you can access it using a method with the same name with the field name. You can also access it using the field itself because the field is immutable, so it have no problem exposing it directly. Basically is a final field, so you cannot assign anything into it. You get a compilation error. Again, so far so good. This is similar to what other libraries are out there. So now, with FunctionalJ, with struct, you can also change the value in the same way, and I call this a immutable modification. So let's say I want to change the first name of this object. I can do this with first name, and then I give a new name to it. So you can see that when I call person dot with first name and give it the name John, it creates person2, which has the first name equal to John, and everything else stay the same. Right? So this is what it means to be immutable modification. So that is actually no modification, just create a new object with a new value. That is actually another way to access and immutably modify the object, which is called lens. We'll do it later. Another unique feature to struct is that it give you a way to handle required and non-required fields. So let's say this person doesn't have a last name. Can we do that? We can't, because this object has two fields, so we have to put both fields in it. What happened though if we put null in it? You get null pointer exception. So basically, the generated class doesn't accept null for anything that is required. In order to say that this object doesn't require the last name, you have to annotate it with nullable. Then it is okay to create a person without the last name. And because it's not required, you can basically opt it out. So there's another constructor created for that. What if I'm okay to not give it the last name, but I don't like it that is null? Then you can also specify the default value. No, default value, and give it to empty. So if the last name is not given, then empty string is given instead. If you put null in here for some reason, it had the same effect. There are other default value that you can use, including null, but let's say you give it to something like 1. Let's clean build a little bit. Then you will see that default value is not suitable for a string. So struct will tell you that the default value is not compatible. So, as I said, there's another feature called lens, which allow you to access to the property field. So what is lens? A lens is a function, is a function for accessing a field value. Let's see an example. Oh, let's put this back first. Okay, we get the person back. So let's say I want to get the last name of this person using fields, using lens. So we can do that by using the lens, which is a static final fields in the person class. Then I can say last name. I normally static import that. So because it's a function, so you need to apply to an object. So basically, this function, the person last name, is a function that given a person can return you the last name. You may wonder why we do this. Just think about this. This is functional programming, right? So function is the lowest, or no, it's not lowest. It's the most basic programmable entity. So that use function everywhere, right? For composition, for whatever. So having a way to access to a field as a function allow you to do lots of things in functional programming. For example, if you have multiple people in a list, I don't know how to spell basically, list of that. Okay, so one person cannot be seen as the people, so I'll add another person. Who should it be? Let's say Tony Stark. Just see first that this works. So Tony Stark and Bruce Wayne, they together become people in the people list. Then if I want to get only the first name, then I can map this to the person first name. There. So I can use lens as a function, use it in something like map or something like that. You may still wonder why is this useful, because you still can do this, right? Right, and give it the same thing. The answer lies with composability, because this is method reference is not a function, it's actually a lambda. So you cannot do something like, and then, but you cannot compose it basically. With lens, you can compose because lens is a function. So you can do something like, and then, or just then, or whatever is in there. For example, to check if this first name is blank or not, to check if it's empty, to check if it's in the collection, or something like that, or no. You can do that. And because it's composable, it's even more useful when you, in a situation that you have multiple, sub-object. For example, if you want to create company object, company can have a name, and company can have a CEO. Right? So we can have companies, and then we can create companies. The name of the first company will be Wayne Enterprise, and the name of the second company will be Stark Industries. Now, I can use the company CEO first name. Right? So because lens is composable, so the company lens can be composed to the CEO lens and can be composed to the first name lens. So this way, if you have a deep data structure, then you can use the lens to go as deep as you want without having to do lambda or whatever. Now, because accessing to read the field is not the only thing you want to do, right? You also may want to do something like modify the object. So let's say you don't want to have Bruce Wayne as a CEO anymore. Right? You can change the name of the CEO, and to do that you can do it through lens. So the company CEO dot first name, and you can change that to something like John. So this function will create you a new company with a new CEO that has a new first name. Right? So without this lens access, you need to create a new person first that have a new first name, and then you create a new company that has a new person as a new CEO. So, but with lens, you can do this in one go. You can do the same with start as well. Right? So you can change the name of the CEO to start, to net, right? You get net start. I don't know if he'd be a good CEO. So that is lens. The next functionality is called Exhaustive Builder. You may be aware of the builder in value, Lombok builder, value, or immutables. And basically, builder allow you to create an object by using name parameter. But in FunctionalJ, you must set all the required fields value. And the required field value must not be null. So let's go back to the simple person situation. Okay, so this person is created using its constructor, right? So let's say how can we do it using the builder. So we can do this by create a builder, assign a first name. This is what I mean by name parameter. Right? So this gives the same effect with constructor. But if you have multiple fields and they're all the same type, it would be helpful to see what value go to what fields. Like Bruce go to first name and Wayne go to last name. As I said, the same will go. You cannot just put nulls in here. You get null pointer exception as well. Okay, so the builder is exhaustive. If you don't give the last name, you get a compilation error and say that you just only give the first name and not the last name. And then what happened though if you have a non-required field? So let's say you have a nullable string of middle name. Sometimes when you make change of the struct, you need to do a clean. to the project. Immediately you can see that the middle name is not a required field, right? So you don't need to specify that. The builder will let you do that. But if you want, you can also specify the middle name in there. Something like that. There. All right. So exhaustive builder will be useful for value object that might evolve as you change your object. You may use builder in some other place, and you may not be aware that those places may not be aware that there are more fields into it. This can be very useful. So validation. In object-oriented programming, you can check the validation of the object in the constructor or in the setter of the fields that you want. But because this is done automatically with struct, we provide the way for you to validate the value of the object. So how that's done? Let's say I create another value object called circle, right? And then it have X as a center on the X-axis and Y center on the Y-axis, and then radius. Then I make it a struct. So far so good. I can create this struct and give it a value. Right? So far so good. But what if I put the negative value in there as a radius? Have no problem. Let's say if our logic doesn't work, it will throw an error somewhere if the radius is negative. We want to make sure that it's validated. To do that, we have to start with changing this specification method to a static method and have it return Boolean. This method should return true if the object is valid and false if it's not. So in this case, we will return if the radius is greater than or equal to 0. Then you can see that with radius 5, everything is okay, but with radius -5, it throws a validation exception. This can be adequate, right? The error message can be adequate. You can look at it and say, oh, radius is -5. But it might not be enough. If you want to be explicit why is not valid, then you want to control the error message here. You can do that by have this specification method return a string instead. So if the value is valid, then you return null, meaning there is no error message. Otherwise, you return the error message. So let's say circle's radius cannot be negative. So when you run that, you will see that positive radius is fine, but when negative, it will throw validation exception with the message circle radius cannot be negative. This is mostly enough. But sometimes you want to throw your own exception. You can do it. First, you have to create that exception first. Let's say it called negative radius exception. The exception have to extend validation exception. So we'll get a radius in there. And then it will assign the default message, right? Okay. So then we have to change our specification method to return a validation exception. There. Eclipse kind of mess up a little bit, so I can do that. There. So if it's positive, then it's create object fine. If it's negative, then it would show negative radius exception right here. All right. So this can be useful in your case. The only problem is it have to extend validation exception. So far, you have seen me create a data value using specification method, which is called a compact form. Compact form is not enough. If you want to generate class to extend some other class or implement other interface or inherit something else or override something else or add additional method. So we can create the object using an expanded form. So let's see how it looks. Let me copy some code here. I don't want to tie them all. Okay. So I have here a greeter class, which is abstract class with one abstract method greet word. So basically, it will use greet word to say hi to whoever the name given when you do greeting. Now, I create a friendly guy spec. The class name have to end with spec or model. And then this class is said to extend greeter, or you can add any implementation or whatever. And it requires to have one field called greet word. So basically, whatever the fields you have, you specified it using public abstract strings. Sorry, public abstract fields with the type and the name in here. So with this, we will get a class called, let me delete this. So with this, we get a class called friendly guy, right? And if we have to say hi, we have to specify what a greet word. Because he's friendly, so we said hi. Okay. Then you can have him greet someone. So let's say Batman. They say, hi, Batman. Right? So this is how you create a struct that extends something and overrides something. You can go further and say this class will, because he's friendly, so he can also shake hand with someone. Okay, do whatever needs to be done there. So this is how we create a value class that extend some other class or implement other class and have its own additional method. That's it for now. I hope you find FunctionalJ.io struct to be useful dealing with immutable data. Next time we'll talk about choice, which is can be known as discriminated union in some languages. For now, thank you for watching. Happy coding. Bye-bye.